Welcome to the session on cloud computing and its application. In this particular session, we will discuss about what is cloud computing, what is the market trend, and we will also try to have an overall picture on how cloud computing works. Okay, let's continue. And in this particular slide, if you see there is an elephant and lot many people are viewing this elephant from different angles. Few of them are seeing it from the front end, few of them are seeing it from the top end, few of them are standing just behind the elephant and trying to explore the elephant, and they're giving their own views on whatever they see. Same way is cloud computing. The way all these features put together makes an elephant, in the same way all the features or all the viewpoints of all of them put together makes cloud computing. In short, what is cloud computing? Cloud computing is nothing but an online computing utility provided with the help of a service provided through a web interface. This is nothing but a Gartner's hype cycle. What is Gartner's hype cycle? Gartner's hype cycle helps us to understand graphically how a technology has grown and what is its market trend. In this particular Gartner's hype cycle, which was developed in 2012, we see a tremendous growth in cloud computing technology. Let's try to overview about what cloud services stands for in market. Just to give you an example, in 2012, the cloud market or the cloud computing market was around $40 billion, and it was predicted way back that it will be $241 billion in 2020, that is the present year, with a growth rate of 20% every year. So by viewing this, and this is a forecast from Forrester's report, by viewing this you understand that there is a tremendous growth in cloud technology and there is a huge market available for cloud technology. Majority of now are deviating from their conventional model of working to cloud computing standards. Again, there is a comparison of few different types of clouds. For example, public cloud in 2011 had a market of around $25 billion, but in 2020 it's around $160 billion. Whereas the virtual private cloud had $7.5 billion in 2020, that is the present year, it stands at $66.4 billion, and private cloud stands at $15.9 billion in 2020, and overall growth of sixfold is seen from 2011, where it was $40.7 billion, and presently it stands at $241 billion. This shows how cloud computing is growing drastically every year, and the market trends. Now when we see this growth, we also need to understand that majority of the small sector, medium sector and big sector companies or IT sectors are now deviating towards cloud. So it's a huge market, and yes, when there is a huge market, naturally there will be many more challenges associated with it. Now, holistically, what does cloud computing mean? Cloud computing is nothing but a standard IT based capability to provide different internet based services like software, like infrastructure, like platform through different internet protocols to the clients. The basic advantage of cloud is it is expandable. We can expand the facilities of cloud when we require it. It is pay per usage. In short, whatever we use, we are billed accordingly. So these are few basic advantages of cloud. So what is cloud? Cloud is nothing but an online computing utility provided by different service providers One more feature of cloud computing, as I told you earlier, it is dynamically provisioning. Now, what do you understand when we talk about dynamic in nature? Let me give you an example. When US government announced that Osama bin Laden was killed, it was first published in CNN, and within few seconds their entire network went down. Why? Because they were crores together hits. People were trying to understand what exactly has happened. Now, in case of dynamically provisioning, in such kind of circumstances, the cloud can automatically expand its network to meet the present requirement. That is what is called as dynamically provisioning. It can enhance its computing capability, its storage, its networking capabilities, and also its infrastructure. And the best part of it is it is on billing metering basis, that is pay per usage. For example, if you are going to use the uh, all these facilities for a limited period of time, you will be billed only for that particular interval. Okay, let's continue. Cloud computing at a glance. Before we go ahead, let's try to understand what a traditional data center looks like, and what how can we compare it to a cloud computing economics. So here is a comparison of public cloud versus data cloud with respect to economics. Okay, so on the left hand side you will see couple of dimensions A to G, and on the right hand side we have Amazon Web Services, which is an service provider for cloud computing, one of the major service provider. And and on the right hand side you see a costing of an in-house data center. Let's check what is the first dimension, that is the purchase cost. When we are talking about a cloud computing technology, there is absolutely no purchase cost at all. Why? Because we will not own the network, we did not bother about the infrastructure, we did not bother about the services, I mean the maintenance cost of it. Whereas to run a data center, approximately we will be spending $9,600. Let's take the cost per hour. When it comes to cost per hour, for an cloud it stands at around $0.68, whereas in-house data center cost stands at around $0.36. Okay, what is the utilization of a cloud, or is the most important aspects why companies are now deviating away from the traditional data centers to cloud? The utilization stands at 80%. That means the any infrastructure which is there, it is getting utilized at its best at 80%, whereas and data center at any given particular time the utilization is at 40%. So here there are a couple of other different dimensions for you to view on. This clearly states that cloud computing has an better advantage over data center. Yes, there are challenges, there are different challenges, there are different issues which cloud computing faces. We will discuss this in the future chapters. In this slide, we will try to understand what is the vision of cloud computing. Now, who can avail this facility of cloud computing? Any person who wishes to rent out any IT infrastructure or a software or an application can approach or can access a cloud service provider through its web interface and opt for the services available. The only criteria is they should have a valid payment mode, because the payment is done on usage basis. Now, who can rent out their infrastructure? For example, if I have excess infrastructure, IT infrastructure, or an middleware, or an application or a software, I can put it across to the cloud marketplace, and any client who wishes to acquire these facilities can approach the marketplace or the service provider like Amazon Web Services and opt for these services on metering basis. These are few of the use cases of cloud computing, infrastructure or IT infrastructure, SaaS, or we can also call it as software as service like email, etc. Dev and testing, that is development and testing. Hosted solution, it might be any kind of packages which can be hosted, and any client who wishes to utilize the facility can opt for it. Content delivery networks, high performing computing, which are basically used in advanced computing, etc. These are few of the test cases which can be used in cloud computing. Typically, cloud computing technology concepts and ideas are depicted in this particular slide. So there is no capital investment, that means, and client did not invest even a rupee for infrastructure development. Quality of service is basically taken care by the service provider, and there are platform as service is available, software as service or infrastructure as service. The basic idea about cloud computing is its elasticity. It is scalable, that is, as and when required, it can be expanded. Security, it is highly secured. Each and every cloud service provider have their own set of protocols to secure the usage of data as well as their services. There are many definitions given by many IT experts for cloud computing, but the gist of it is an on-demand network access which has a pool of resources like networks, servers, storage area, application, software, which can be used by a client on billing or metering basis. It is rapidly expandable or scalable and can be utilized as and when required. There is no infrastructure cost which a client needs to take care. Basically, there are three types of cloud deployment models. The first one being public cloud. What is public cloud? Public cloud is nothing but wherein different third-party vendors can provide their services like storage, computing, application, software, or any packages to the clients. clients who have a valid credentials or valid account can actually access these services and pay on usage basis. The second one is a private cloud. What is this private cloud? Private cloud are basically meant for a group of users. For example, if there is a bank can have a private cloud, and all those facilities like the storage, computing facilities or application can be used internally for the members of this particular bank, or in short it is a private association kind of thing. What is this hybrid cloud? Hybrid cloud is nothing but a combination of private cloud and the public cloud, wherein a client can either approach the public cloud for certain facilities which are not present in their private cloud. So in short, these are the three deployment models of cloud computing: public cloud for public usage, private cloud for internal or a private sector usage, and a hybrid cloud where each client can either opt for services outside their private cloud or which are not present in their private cloud. They can take these services from the public cloud. So as I discussed earlier, we have three development models, or sorry, deployment models: the public cloud, the private cloud, and the hybrid cloud. And explanation about the same is given in slide for your reference. Here are few of the attributes of cloud deployment model. One is its broad network access. In short, it can be accessed from anywhere from any location if we have good internet facilities. Rapid elasticity, that is, it is scalable. We can upscale or downscale our requirement as and when it is needed. Pay per usage, that is, we pay for the services on metering basis, on demand services. Also, there is a huge pool of resources which can be utilized as and when required. Now, cloud computing is being categorized into different service model. The first one is software as a service. Now, what is this software as a service? For example, any softwares, maybe your email or payment methods, which the cloud service provider can provide to us. Platform as a service, like middleware, where we can go and opt different platforms and use for development or testing purposes. Infrastructure, as you know, it is nothing but computing power, your storage power, network power, and desktop. Now there is one fourth one which is there in the market, that is XaaS, that is nothing but anything else as a service. Now, so maybe any kind of other facilities which a cloud service can provide is categorized or it falls under XaaS. So there are four deployment models. Majorly, we speak about software as a service, that is SaaS, platform as a service, that is PaaS, and infrastructure as a service, that is IaaS. So again, in-depth explanation about what software as a service is all about. It is an end user application wherein anyone can log in and use this application. Office automation, photo editing, CRM, social networking, and the best example is Facebook. We have Salesforce, Google Document. These all are software as a services. Platform as a services, as we discussed in the previous slide, it is a runtime environment for applications, and anyone can actually go and develop their products, or they can code using these applications. The best example or the best service providers for this is Windows Azure, we have Hadoop, we have Google App Engine, and the one Aneka, which you are going to study in future chapters. Infrastructure as a service, as we discussed, storage or networking facilities or virtualization of the services. The most well known is EC2 or Amazon EC2, S3. These are both of Amazon Web Services, and we have vCloud. Few characteristics and benefits of cloud computing. We have already discussed this in the previous slides. I'm not going to explain this in depth, but no upfront commitments, on-demand access, competitive or I can say nice pricing or rates, effective resource allocation. It is energy efficient and seamless creation and utilization of all resources to the best of its ability. These are few benefits of cloud computing. So the same is been categorized over here. Let's just talk about the risk factors of each of the service models. In infrastructure as services, when and as per the survey, security plays a most important role. Why? Because all your data will be in the cloud service providers infrastructure, that is a third party infrastructure. Data persistency, data aggregation, business risk like outage might be a major issue. Service failure, for example, you will be relying on some infrastructure of a third party, and if there is a service failure, then it might create a major issue. Whereas for platform as a services, the risk factors are almost same as above, but the add-on is vendor lock-in. What is vendor lock-in? For example, the vendor in between may say that I will not be providing these services and may eliminate the services. In this case, it might be a major challenge. Software as a services, again, all the risk factors are same as infrastructure as services, but the one and platform as a services, but one add-on is lack of control, as in you will not have any control over the software. Why? Because the software is running in the cloud environment and you are just using these facilities. So in short, as a client or as an end user, you will not have the entire control of the software. So these are few of the benefits, risks which we have seen in which we have spoken about. We have also listed few key characteristics like agility, cost. We have already discussed device and location independence. What is this device and location independence? For example, we need not rely on a single system or a single PC or a single laptop. It is device independent. Why? Because we will be using the facilities on the cloud. We can sit anywhere, anytime, in any location if we have a stable internet service provider, and if we have a stable internet facility, we can utilize these facilities sitting in any corner of the world. Multi-tenancy is one of the other key characteristics of cloud computing. It enables sharing of resources, centralization of infrastructure in areas with low cost such as real estate, electricity, etc. So these are few of the key characteristics. There are few more in the reliability. Yes, it is reliable in nature. Each and every cloud service provider have their own quality of services they provide. Scalable, as we said in the earlier slide, it is dynamic in nature. It can be upscaled or downscaled. Sustainability is there. I mean, there is continuous resources which are added, or there are primary and secondary resources which are kept on hold in case of any kind of risk factor or any kind of emergencies. So let's try to understand what are the concerns or what are the challenges of cloud computing. Loss of control, yes, that's a major issue. For example, in case of infrastructure as service or storage, once the data is sent to the cloud service provider where a data is going to be saved, the client will have no control over the data. The data can be saved anywhere in any location. That's the reason we say loss of control. Same way it implies even for software as a service and platform as a service, we will not have the control of the application or the software because it is maintained and managed by the service provider. Integration, There might be many challenges which we have to face with respect to integration of enterprise or the local authorities or the local laws. It is a challenge. It is a governing challenge. Interoperability with key enterprise application might be a challenge. Accessibility and UI limitations, reliability, performance, security, and offline access. Offline access is not possible in cloud computing. We need to be online. These are few of the cloud computing concerns which we have already discussed: policy, breach or forensic, and legal issues might be a challenge. So here we have listed down a couple of cloud challenges which are self-explanatory.
Next, we will look into historical developments. The idea of renting computing services by leveraging large distributed computing facilities has been around for a long time. It dates back to the days of the mainframes in early 50s. This process has created a series of favorable conditions for the realization of cloud computing. We briefly review five core technologies that played an important role in realization of cloud computing. These are distributed systems, virtualization, Web 2.0, service-oriented computing, and utility computing. First one we look into distributed systems. What is distributed system? Distributed system is a collaboration of independent computers that appear to its user as a single coherent system. The three major milestones that have led to the cloud computing are under distributed system are mainframe computing, cluster computing, and grid computing. So what do you mean by mainframe? Large mainframes are large computational facilities leveraging multiple processing units. Even though mainframes cannot be considered as a distributed systems, they offer large computing power by using multiple processors which were present as a single unit to a user. Now another type is clusters and one more is the grid. The major difference between the cluster and a grid is cluster is we can consider as an alternative technology for mainframes or a supercomputer where we used group of computers connected together which appears to its user as a single unit, and even grid is a group of computers those are connected together which appears to its users as a single entity. But the main difference between the cluster and the grid is clusters are homogeneous and grids are heterogeneous, meaning the computers that are the part of grid can run different operating systems and have different hardware, whereas cluster computers all have the same hardware and the operating system. Next, we will see virtualization, which is another technology that played an important role in the realization of cloud computing. So what you meant by virtualization? Virtualization technology is one of the fundamental components of cloud computing, especially in case of infrastructure based services. It allows creation of secure, customizable, and isolated execution environment for running application even if they are untrusted without affecting other users application. Now if you talk about virtualization, there are different types of virtualization. uh, That is, we have hardware virtualization, we have software virtualization, we have compute virtualization, we have storage, we have network, and we have desktop virtualization. Like this, there are n number of virtualization available. We will talk about more on virtualization in our coming chapter. Next technology.
Now let us talk about the third technology, that is Web 2.0. The web is the primary interface or medium through which cloud computing delivers or provides its services to everyone. So basically Web 2.0 is in the current state of online technology has it compares to the earlier days of web. It comprises by great user interactive and collaboration and enhanced communication channel. The Web 2.0 is used to elaborate the second generation of WWW, that is World Wide Web, which moved from static HTML pages for more responsive and interactive as well as dynamic web experiences with Web 2.0. So this is widely used in the present cloud computing technologies. Example of Web 2.0 applications are Google Document, Google Map, Facebook, Twitter, YouTube, etc. The next concept in this slide is service-oriented computing. Service orientation is the core reference model for cloud computing system. This approach adopts the concepts of services as the main building block of application and system development. Service-oriented computing, also called as SOC, supports the development of rapid, low-cost, flexible, evolvable application and system to meet the business objectives and also to provide value to the customers. The two main concepts are quality of service and software as a service. Now, what is this quality of service? Quality of service identifies a set of functional and non-functional attributes that can be used to evaluate the behavior of the service from different perspectives. These could be performance metrics such as response time or the security. Quality of service requirements are established between the client and the service provider with help of SLA, that is service level agreement. Now, the concept of software as service introduces a new delivery model for application. The term has been inherited from the world of application service provider, that is nothing but ASP, which delivers software services based solution across wide area network from central data center and makes them available on subscription or rental basis. This software delivery model is possible because of its economy of scale are reached by means of multi-tenancy. In short, the best practice is possible in SaaS, that is software as a service, because of multi-tenancy. Now, let's talk about utility oriented computing. Utility computing is the process of providing computing services through an on-demand pay-per-use billing method. Utility computing is a computing business model in which the provider owns, operates and manages the computing infrastructure and resources and the subscriber accesses it as and when required on rental or metering basis. Utility computing is one of the most popular IT service model, primarily because of the flexibility and its economy in it provides. This model is based on that used by conventional utilities such as earlier style of telephone services, electric services or gas services. The principle behind utility computing is very simple. The consumer has access to a virtually unlimited supply of computing solution over internet or a virtual private network which can be sourced and used whenever it's required. The backend infrastructure and the computing resource management. Also, the delivery of this utility is governed or provided by the service provider. Utility computing solution can include various virtual servers, virtual storage, virtual softwares, backups and other IT solutions. Cloud computing, grid computing and managed IT services are based on the concept of utility computing. Now let's talk about few computing platforms and its technology. The first one would be Amazon Web Services. Amazon Web Services is the world's most comprehensive and broadly adopted cloud platform, offering over 175 fully featured services from data centers globally. Millions of customers, including fast growing startup, largest enterprises and leading government agencies, are using Amazon Web Services to lower their cost, becoming more agile and innovative faster. It is a subsidiary of Amazon, providing on-demand cloud computing platform and API to individuals. These cloud computing web services provide varieties of basic abstract technical infrastructure and distributed computing building blocks and tools. Few of these services are Amazon Elastic Compute Cloud, that is EC2, Simple Storage Services, or we can also call it as S3. Next platform and the technology would be Google App Engine, or it is also referred as GAE, or in simple App Engine. It is a platform as a service and cloud computing platform for developing and hosting web application in Google managed data center. Applications are sandboxed and run across multiple servers. App Engine offers automatic scaling for web applications as the number of requests increases for an application. App Engine automatically allocates more resources for the web application to handle additional demands. Google App Engine primarily supports PHP, Java, Python, .NET and Ruby. Microsoft Azure, commonly referred as Azure, is a cloud computing service created by Microsoft for building, testing, developing and managing application and services through Microsoft managed data centers. It provides software as a service, platform as a service, infrastructure as a service and supports many different programming languages, tools and frameworks including both Microsoft specific or third party software and systems. Azure was announced in October 2008. Microsoft Azure is an ever expanding set of cloud services to help you organization meet their business challenges. You would have heard of Hadoop. Hadoop is an open source software framework for sorting data and running application on clusters of commodity hardware like computers or multiple computers. It provides a massive storage for any kind of data, enormous processing power, and the ability to handle virtually limitless concurrent tasks or jobs. As a World Wide Web grew in the last 1900s and early 2000, search engines and indexed were created to help locate relevant information aimed to text-based content. Hadoop has played a very important role in this aspect. Salesforce.com, or also called as force.com, is an American cloud-based software company. It provides customer relationship management services. Salesforce is world's number one customer relationship management, that is CRM platform. Salesforce helps marketing, sales, commerce, services, and IT team works as one for any way. This is the last one which we will discuss in brief, that is Aneka. Aneka is an application platform as a service for cloud computing. It acts as a framework for building customized application and deploying them on either public or private cloud. All the above topics will be explained in detail in future chapters.